So now how do you work it out? How do you work out flushing time? So now the assumption is that you have a hydrodynamic model that simulates all the relevant dynamical features in your region of interest. Can be an estuary or a bay, as shown here. So you have a model that can simulate the tidal currents, that can simulate the density-driven flows, the wind-driven flows, and you are confident that the model does a good job. So now, how is flushing time calculated? Flushing time is calculated with the use of an artificial tracer of a dissolved substance. Okay? It's like a color tracer, if you like. So you initiate this tracer in your model at a certain start time, and you fill your bay with an initial concentration of 100%, as shown here in this sketch. This is your initial distribution is 100%, and in the ambient ocean, the concentration always stays at 0%. So this is what we call a conservative tracer, which means that the concentration can only decrease over time. And there are two ways it can decrease here in this example. For example, the currents can move in ambient water from the ocean and the concentration is 0%. So overall, the concentration will drop in your bay. Okay, always the water that comes in is new water from the ambient ocean as a 0 concentration. Alternatively, it can be also mixed. You always mix in and drain 0% water from outside. So now, over time, the concentration in your bay will decrease. Okay, it can only decrease. And typically, this decrease is exponential. And this is shown here in this sketch. Okay, I turn on the pointer. You start with 100%, and over time, it decreases the concentration. Okay? And exponentially is a little bit tricky because it never drops to 0. It turns very small. So what scientists use is a so-called E-folding threshold. And this is, you work out the time at which the concentration falls below a threshold value of exponential of minus pi. This is about 1/23rd, 1/23, 4.3%. Okay, and this is the threshold that I was referring to. And this gives you the flushing time. Okay, in this graph, it might be, if this is in days here, it might be about 3 days. You can also subdivide your region into smaller subregions and work out the flushing times for individual regions. Okay, and indeed it only is reliable, this method, if you have a calibrated and validated computer-based hydrodynamic model. Okay, that is the assumption. I show you an example. Okay, and what we do is we actually focus on an area which is not a semi-enclosed area, which has actually 2 openings. It's a strait, and it's called Bass Strait. So let's have a look at Bass Strait and how does the flushing time look like for Bass Strait.